In this module, we're going to be talking about soldering, but before we begin, let's take a little bit of inventory of all the tools that we'll be using. The first thing that I'd like to point out to you, we have here a power strip, and I'm going to use this piece of cardboard as sort of a pointer, and that's a useful thing so that you can collect together all of your devices that need power, but also should something go horrifically wrong, you can just turn this off, everything off, with a single kill switch. Right, so having a barrier strip at your workstation is pretty important, and it's a detail that you should really pay attention to, whether you're doing it in the lab or doing it at home. And so the next thing I'd like to point out is this device that you'll see here. Let me release the camera here. And that device has an intake. It's sort of a mini snorkel, and it creates a vacuum, so there's a fan in the back of it, and there's an air intake underneath here. And when you're soldering, you don't want to breathe in those fumes for safety reasons. You collect them in a vacuum system, and this particular portable snorkel for home use and bench use, it takes the air in this vent here over the work area, and it brings it through the tube into this box, and inside of the box is a carbon foam filter. And so it inputs or takes in that air, that exhaust from the solder, and it filters it to clean up all of those materials that are in the air from the solder, the smoke, to clean it up a little bit or a lot. And so that's an important piece of equipment. Now, this is a portable snorkel. In the makerspace facility, you'll have more industrial grade snorkels. They're larger, coming from the ceiling, and they vent through the air exchange through a scrubbing system. So it's just a bigger version of what you see here. Then we have over here, I'll just point that out, we have some hookup wire. And this hookup wire is in a spool, and this is, I believe it's 22 or 24 gauge wire. And this is solid core wire. And there's a standard when you're wiring things together. You use black to represent ground, or your ground reference for voltage, and you have a bright color typically for your voltage carrying signal. And then you can choose whatever color wires for your wire management of your choosing for the signal wires. And so you generally have three categories of wires in your circuit. You have power, you have ground, those are very important, and then you have your signal wires, and those are involved with the particular control of the device, be that to get data from a sensor or to send commands to some actuator. Then along the bottom here, let me tilt down, we have a bunch of tools for managing the wire, cutting the wire. Here we have a very basic in the middle wire stripper. Let me bring that into view of the camera. And this wire stripper is used to get the polymer or plastic insulator off of your conductor, off your wire. And so this is almost like a pliers. It has a handle. Let me see if I can do this with one hand. You see this notch on the end of the wire cutter, wire stripper. This does two things. It cuts wire and it strips wire. And so you notice as I close this wire stripper, you'll see that hole by lining up the two notches on the, call it a beak if you want to, of the wire stripper, gets smaller and smaller and smaller. And so effectively, when you insert the wire into this notch and you close it down enough, not too much, if you close it down all the way, you're going to cut the wire. But if you close it down enough, it'll grab onto the insulation and you pull, allowing you to remove the insulator from the wire. So let me give you a brief demonstration. I'm going to cut the green, which is bright color, so it shows up very nicely. And so here, let me see if I can zoom in a little bit so you can see that a little bit better. I have my insulator, and the autofocus is not helping us. Let's see. Let me zoom out. So here we have our insulator, and our insulator is covering the wire. And I'm going to go ahead and I'm going to put the notch over the wire. I'm going to dig into it and I'm going to pull. And so if I do that right, you should see now that the wire itself, the metal of the wire, has been revealed, and there's part of it where it's bare wire, and you can see there's part of it where there's insulator. And so we have two things. We have the metal, the wire itself, which is a conductor, and then we have the plastic sheathing, which is an insulator. And that insulator does not allow the flow of electrons. You need an insulator over your wire so that you can have signal carrying wires, voltage and ground that are stable. If the two parts of the metal interact with one another, they touch, you're going to get that electricity, that current, those electrons flowing from bare metal to other pieces of bare metal. So here we have our wire stripper, and you notice if we do not put the wire in the notch, that cuts the wire. So I'll demonstrate that. You notice it's not in the notch, and here, let me turn it sideways, I cut the wire. And so typically when you're wiring together a circuit, you're going to measure your length of wire, and it's always good to make it a little bit longer than you need, because if you make a mistake, you can still cut it off and have adequate length for your application. And so that's a little bit about this wire cutter and this wire stripper. Now here to the left of it, we have a fancier version of the wire stripper. It also does wire cutting. And what you'll notice here is that on this particular wire stripper, you'll see different pairs of notches, and there'll be a number above them. Let me turn it this way. And that number represents the gauge, which is a measure of the thickness in millimeters. There's an equivalent measurement of the wire. And so wire comes in so-called gauges, and these gauges represent the thickness of the conductive material, which is the wire itself. Now, why do you need different gauges? Because if you have a higher flow of electrons, a higher current going through your circuit, you generally need a thicker or a lower gauge wire. The smaller that gauge number, the thicker that wire. And so if you had, for example, 10 milliamps or 100 milliamps of current, something like a 22 gauge or 20 gauge is sufficient. But if you had something like 15 amperes, 15 amp, which is a typical current rating for a standard household circuit, you're going to need something much bigger than a 10 gauge. You're going to need a thicker wire, because it's the thicker the conductor is able to transport a larger bulk number of electrons flowing over the valencies in the material. So this is the fancier one, and just like we saw before, we can actually strip this wire to take off the conductor, and you need to strip wire when you're going to do soldering. And so here we choose our notch. Let's choose 22 for 22 gauge, and now when we press this, these notches are perfectly measured. Let me cut that again and show you again for the specific gauge of wire. So here I have my 22 gauge solid wire, and now when I hold it down, that notch is pre-drilled for the right thickness for the particular gauge of wire, and I just pull. Now I guess you could say I'm old school and I use the more basic stripper because I've been doing this for a while, but certainly there's no harm in having the more fancy wire stripper where the gauges are measured. Likewise, inside this part of the wire cutter, we don't have a notch, and that's going to be cutter, but the notches are going to be the strip connections. And so what else do we have? Here we have this thing I call a lobster. It's a holder, and that holder is useful for orienting your wires and your components correctly in place when you're doing your soldering. Now when you solder, you kind of want to have your hands free. So having this notional extra set of hands is very useful for holding your device. Now I call it a lobster because if you look on this device here, you have one arm, you have an alligator clip, and you have another arm. So it kind of looks like the claws of a lobster. And then you have a little spiral here that's used for holding your hot soldering iron, and then a magnifying glass so you can see a little bit better what you're doing. So typically what you would have is you'd have one conductor on one side in an alligator clip. Let me show you that. We have another conductor held by the alligator clip, and you would manipulate this to hold those conductors together so that you can very easily solder. So let's try that out. So I'm going to hold in one of the alligator clips a conductor here for the green wire, and just for good measure, I'm going to cut a length of, let's say, red wire, and I'm going to strip that with my 22 gauge wire stripper here. So I'm going to go ahead, I'm going to strip that, and now that I strip that, I'm going to go ahead and I'm going to have the lobster hold the conductors in place. And so now, here, let me move that a little bit more. Here, I have my two conductors held in place, and I can actually mate them together so that they're touching. And that is a lot easier when I'm soldering to have that extra set of hands holding them in place. Now this is generally adjustable, so let me adjust this a little bit. And in this case, I'm just going to touch them together a little bit as kind of a crossing pattern, if you will. And now it's holding it in place. So if I wanted to solder them together, that's a lot easier than having a shaky hand try to hold it. So that would be my lobster or my solder holder. Next, we're going to take a look at the safety goggles. Now the safety goggles, it's very important. I wear glasses, but certainly if you do not wear glasses, you want to make sure you have some safety goggles. When you cut wire, especially this wire that is the solid core wire, it's not uncommon for a small piece to go flying off to the side. So that also says when you're cutting wire, you don't want to point it at somebody. So here, let me demonstrate. Let me get a piece of yellow wire, and I'm going to go ahead in front of the camera, and I'm going to go ahead, let me zoom out a little bit. I'm going to go ahead and I'm going to cut a piece of that wire. So when I cut it, well, that doesn't fly too badly, but the stiffer the wire, sometimes these pieces can launch out. And when you launch them, because they're metal, you wouldn't want it to shoot and scratch someone's eye. That would be pretty bad. So it's important to wear goggles rather. Now, of course, I wear glasses, and these glasses are over my eye, so if something should shoot out, it's not going to hit my eye. And then lastly, we have the soldering iron. So let me zoom out here. Now, this particular soldering iron is a temperature-regulated soldering iron. Let me right the camera. And this temperature-regulated soldering iron allows you to set a specific temperature for the soldering iron. Now, that's very important for getting a good solder joint when you're building your circuits. So you could be soldering together two conductors, you could be soldering a conductor to a component, you could be soldering a component onto a circuit board. Either way, you want to make sure you get a good solder connection. And this particular soldering iron, it has your station here, and that station has a temperature controller which allows you to dial up and dial down the temperature, and it will regulate that. And so it pushes more current into the soldering iron should the temperature drop. It pushes less current into the soldering iron should the temperature rise. And that voltage is what heats up the coils on the element for the iron. So that's the station, and it's currently off. And then here we have another receptacle for holding the hot soldering iron. This is not plastic. This is a special polymer, and it's formulated to withstand the temperatures of a soldering iron. And the base here is metal. So here's a soldering iron. It's a so-called pencil tip, so it looks like a pencil, soldering iron. And it's really, really important not to touch these metal parts. It'll get very, very hot and give you a very nasty burn, right? You don't want to do that. So here we'll start out and we'll put the soldering iron back into the receptacle, and then we're going to set a temperature. Now, I like to go about 500, 530 degrees. That works for me. But one of the consequences of a really hot soldering iron is that you're going to spend less time with this tip held against, in particular, things that are circuit boards and components themselves, because it's going to heat up and you can actually melt or burn your component by holding a really hot soldering iron against it for too long. But the trade-off is, with a hotter soldering iron, you're going to melt that solder much faster and have your connection made in more rapid fashion. So I like to use a regulated soldering iron, and I like about 500 to 530 degrees. But depending on the application, there are applications where you might want to go cooler, especially when you're dealing with computer chips, or hotter, when you don't want to spend really much time. And another parameter to consider, and we won't consider that for my class, is the type of solder tip. Some tips look like flathead screwdrivers. Some tips like this, the pencil tip, it's basically a cone that's very thin, and you can have tips that are longer, tips that are shorter, tips that are very thin, and tips that are very wide. It all depends on how close in all the components are that you're trying to solder. So let me put that back in, and one of the things you'll also notice is we have a sponge. And this sponge is very important for cleaning the tip. You want to clean the tip of your soldering iron very frequently, because what ends up happening is you get chemical residue, you get imperfections, and you get burnt up solder over time accumulating on your iron. And so that is not very well conductive. You want to have a freshly cleaned soldering iron, and you'll see once I start an example of soldering that I frequently clean my iron. Lastly, we have this device. This is called a solder extractor. Some people call it a solder sucker. And this is a vacuum triggered by a mechanical force. So let me engage it. And when I do that, you see this plunger pop up. Now, inside of the cylinder is a plunger. And when it pops up under spring loading, it creates a vacuum. And this is used, press this nozzle against your soldering joint to extract or remove solder that has been placed on your conductor or component or board. Now, of course, you want to touch this onto that connection, heat it up with the soldering iron, and then extract it, and it'll remove that solder. Okay, so why don't we go and turn this on, but before I begin, I'm going to keep a bottle of water handy because I'm thirsty, but also because we want to make sure this sponge is very well moistened, right? You don't want to have it swimming in water, but you definitely want to saturate it so that it's sopping wet. And so I'm going to go ahead, and I don't want to touch the mouth on there because you don't want to ingest any residue that's sitting on the sponge. And I'm just going to pour some of that water into this little well in which the sponge sits, and sort of take your time. And as I do that, you see the sponge, as it fills with water, it sort of reconstitutes, right? So it's like it's freeze-dried being reconstituted. So I'm going to go ahead and I'm going to saturate that sponge, and you'll see it kind of swell up a little bit, doing its thing. So let me go ahead. Oops, it's a little bit too much. I didn't want to do that. And we're back. So cleaned up the mess, and that's just a demonstration, really, of taking your time with infusing your soldering sponge with water. But that's pretty important, and as you can see, it's wet, very soggy, but not really a pool of water in which it's swimming. And so now what we're going to do is point out to make sure that you have awareness at all times of what the state is of your workspace. And so here, I know my tools are down here on the left. I know my snorkel is up along the middle, going over the top. I know my barrier strip is off to the left on the right. My wire is here, and this is my spool of solder. Now, this particular solder is rosin core tin lead based. They have lead-free solder, but I found just in building circuits and things like that, that the lead-free solder is not always as good as the lead-based solder. Now, of course, what I found is that the lead-based solder gives you better connections, but it also doesn't require the same types of temperatures. So maintaining situation awareness could be the difference between having an accident and having a pleasant experience in soldering whatever it is the circuit is that you're building. Now, of course, if I knew something catastrophic was happening, I'd immediately reach out and I would turn off the barrier strip, shutting everything down. I know that my soldering station is off on the right, and that's on purpose. If I were to accidentally knock over my soldering iron, it would go off the table and not here into the workspace. I know that my lobster is here in the middle, and so the first thing I'm going to do is I'm going to turn on my soldering station. And I'm going to set the temperature to about 520 degrees or so, and that will heat up in very short order. It's about 240 now, and it'll give you feedback about what the current temperature is of the soldering iron. And you'll see once it warms up very quickly, it will race up to 520, and you'll see it fluctuate up and down a little bit once it reaches that set point. And so this solder station is a nice thing. You don't have to worry about the temperature. It does all the work for you, and it has a controller that will actively regulate your temperature. So now, once we're about there, let's go ahead and let's get the spool of solder. Now, with the solder spool, I don't like to hold the whole thing, so I'll typically get a length of solder, and you can break this with your bare hands. So break it. I'll set the spool back down, making sure I'm managing my workspace very nicely. And then I like to coil it up in a small coil and then have a piece of solder sticking out that I actually work with. So this is my working solder coil. It's a little bit too kludgy, too bulky to carry the spool by hand. So now I have my solder, and I'm just going to hold it up to the camera, but I wouldn't do that in practice. The first thing I do, and that's sort of in my muscle memory, is I go ahead and I clean my soldering iron. So you notice when I touch the sponge, the soldering iron gets cleaner. You'll see it's clean because it's a little bit brighter on the tip. I'm getting all of those charred elements, the schmutz, if you will, off of the soldering iron. And so you'll notice the temperature drops a little bit when I touch the sponge, and that's because of the evaporation of the water off the sponge. So now let me show you a little bit about what happens with the solder. I'm going to go ahead and I'm going to touch solder on the soldering iron. And you notice it melts, and I have a bead of solder, almost like a little drop of water. And as I touch, I feed that solder onto the soldering iron. Let me go ahead and clean it off. Let me turn this up to 550, a little bit hotter, so it's more responsive. And we'll let the temperature go up. And so now I have this bead of solder. Let me build up the bead a little bit more. You see that bead of solder? It melts. And so I'm going to show you the solder sucker. You don't want to ingest this. Let me turn up. And you notice the fumes go up. So I'm going to go ahead and I'm going to cock my solder extractor. You see the bead and then the extractor. See the bead and then extract it. So let me put the solder sucker back down, back where it should be, so I maintain situation awareness on my work area. So I'm going to clean off my soldering iron, and I brush it on one side, then turn it over, brush it on the other side, turn it over, brush it on the other side, back around. Some people like to really do that, but I don't like to stick it in the sponge because that cools it down too much. So now let me zoom in and on the lobster, and I'll zoom in, return the soldering iron back to its station, and I'm going to zoom in on the joint between the two connectors. And so one of the things I want to do, I'll first illustrate with a piece of cardboard, pretending that's the soldering iron. And so here, you're going to have two things. You have your conductor, you're going to have your two conductors. You're going to have your conductor, you're going to have your soldering iron, and then you're going to have your solder. So these three things, we have our conductor here, we're going to have our soldering iron, and then we're going to have our solder. So typically what happens, you wet the soldering iron with your solder, and let's let that warm up. Oops. We'll melt a little bit. You wet the soldering iron, and then you hold the solder on one side of the conductor, the soldering iron on the other side once it's wet. So you clean frequently, you wet the soldering iron, and then you put the soldering iron, in this case on bottom, the solder on top of the conductor, and then as you melt the additional solder, you feed the solder onto the conductor's release, clean. And so now what happens is you have the wet hot solder on the soldering iron underneath, you touch it against the conductors held together, that heats up pretty significantly. You feed more solder, and that solder is going to adhere, almost like capillary action, adhere to the conductors, bonding them together, release. So that's clean, wet with solder, put the bead on the conductor, feed more solder on the other side, release. Okay. This is the soldering process, and if I bring the connection very, very close to the camera, you'll see that there's a pretty nice connection here. Let me release the lobster, and I'll show you a close-up of what this connection looks like. I'll release the lobster on one side, not both sides. And let me go ahead and zoom in, and you can actually see this connection. So here, you have that connection. So it's a very nice bead, and you want to have as little solder as possible for your connection. Let me see if I can get this really, really close. Right there. So, and it's not the bead, the wetted soldering iron that solders, it's the solder that you feed on the opposite side of the conductor. Because the soldering iron that is wet heats up the conductor, and then when you feed the solder on top, it crawls onto the conductor, adhering to it, creating a good link, a good solder joint. And so this together is your soldering process. You really, really want to make sure you maintain situation awareness of what's going on in your workspace, because the last thing you want to happen are accidents to occur. So again, to repeat, just to reinforce this, drive it home, clean some more, let it come back up to temperature, wet your soldering iron, you see the bead, shiny, touch, and feed. And now I just unsoldered, right? So let me put that back, and let's create that joint over again. Now that's a very simple joint, and mind you, these conductors are going to get very hot because they're being heated up to about 500 degrees. So here, let me go ahead, and I'm just going to wrap these two conductors together to create the basis of a nice joint, and I'm going to try that again. So clean, get all of that solder off. I don't like that solder that's on there, so I'm just going to use a solder sucker and remove that. Okay. Oops. Put this back together, back up. Here we go. The lobster fell. Return that to its holster. Let's try that again. So I accidentally bumped it. So let's go ahead and let's connect it together. And let me see if this will cooperate. Sometimes you'll need the needle nose pliers I'm going to create a little hook this time. And this hook, I'm going to use the needle nose pliers to anchor it down. And I'm just going to put them together like that. Now, of course, if I were to pull them, they would pull apart very easily. And so I'm going to zoom in a little bit, as much as I can, and I'm going to show you the same process. So we take our soldering iron and we clean, we wet, we see the shiny bead, soldering iron down below, heats up the conductor. Oops, not quite as hot. Soldering iron below heats up the conductor. When we feed, as we feed, you'll notice it fills the gap and makes a nice solder joint. And so return to the holster, and there we have it. This is a beautiful solder joint, and as you can see, this solder joint, the gap between the conductors is nicely filled. And let me disconnect the lobster claw here, and you can actually see what that joint looks like. Let's try it from different angles. And so I'm just going to take this joint and I'm going to turn it over, and you can see it's almost welded together. You have that molten solder is now hardened into metallic substance, creating a very nice joint. And if I were to pull this, it would not pull apart. I'm tugging on it pretty hard. That is a really nice solder joint. So that's an example of soldering. In another module, we will demonstrate soldering for wiring things down to a board. These are putting two conductors together. So until then, till next time, we'll see you then.